We have Maddie. I worked really closely with this project. I think she did great. We were a great team. I'm really proud to see her present.
All right, thank you. Hi, my name is Madeline Woodhouse. I go to the Girls Leadership Academy in Wilmington, and my presentation today is on microbial cementation in coastal sand dunes. This project is really important to me as someone who lives on the coast because I see the effects of dune degradation firsthand. The overview of my project is about how coastal sand dunes are crucial for natural coastal protection, reducing flood risks, and supporting global nutrient cycles. My goal for this research project is to identify native species that are able to strengthen dunes via MICP. MICP is a microbially induced calcium carbonate precipitation, which is a naturally occurring process in which binding sand grains together through calcification, resulting in biocementation. A little bit of background is coastal sand dunes occupy around 8% of the Earth's surface and are taxonomically rich and productive ecosystems. They are vulnerable environments and remain relatively understudied, and prior studies to MICP in coastal sand dunes have identified a method for strengthening dunes via spraying the dunes with bacteria capable of MICP. My concern with this prior study is that they didn't use a native species and that they could have used a non-native species, which has a risk of invasive species in an environment. For my methods, I started out by collecting wet and dry samples near me at Wrightsville Beach in North Carolina. Samples were then diluted in a series of 1 and 10 and spread plated onto TSA plates for growth. The individual colonies were isolated and packed onto more TSA plates, and after growth, colonies were gram stained to identify cellular morphology. And gram staining essentially is staining bacteria to identify what kind it is by shape and color. Plates were then inspected for differences in the colony and cellular morphology, and the colonies with distinct morphology were selected and transferred to urea plates to check for urease activity. A color change from orange to bright pink represents urease activity. And you can see these pictures in the very top left. You can tell the one on the very right, labeled 24, is very pink, and the one on the left is still orange, so that one didn't grow, but the one on the right did. And down here, you can't really tell, but it looks orange, but both of them actually show urease activity. It's just a little bit, but they both show pink. And this one had 0 urease activity because it is still orange. Colonies that showed urease activity were then added into cementation media with sand, which is the recipe for cementation media here. And the tubes, including my control sample and 3 replicates per sample of the cementation media with sand, were allowed to incubate at room temperature in the shake and bake for 1 week and then observe for combing. My results, the bacteria effectively precipitated the carbonate and aggregated the sand in the clumps within the tube. When the tubes were rotated, containing the aggregated sand samples, the sand within the bottom of the tube remained cemented together and did not move. This is in contrast to the control sample where the sand slid down the side of the tube. And you can tell in these images they were actually taken yesterday because that was when we were able to finally take them out and observe them. The one on the very left is kind of broken up because it was very hard to get the sand out of the tube because of how cemented it was together. Yeah, Miss Emily and I kind of struggled with that, but you know, we got there. This one in the middle was very exciting to look at. This large clump of calcification actually survived somehow. But this one, you can't really tell, but there are still clumps of calcification shown here. In this video, the left is a control and the right is the cementation. You can kind of tell in the control how it slid down the tube and the experimental stood still. And the experimental one is what happened with the other replicates. So just kind of stay the same like that. My discussion, the experiment revealed significant potential for MICP and coastal sand dune stabilization. This is a promising approach for enhancing the structural integrity of sandy soils and serves as a potential sustainable and eco-friendly solution for coastal erosion management. The next step would be continuing the experiment on a larger scale and eventually transitioning to testing it in an isolated dune area using the spray method outlined in the previous studies. Here are my references for the previous studies mentioned. And I would like to thank NCSSM and Summer Venture staff, counselors, and faculty at ECU. And a lot of thanks to Dr. A and Ms. Emily for bearing with me throughout this struggling process. I did mess up quite a bit, but we got here. It worked in the end, and it was very exciting to do. And I couldn't have done this without my parents over there. And everyone's encouragement towards me has been a strengthening motivation. And I love you guys, my friends I've made here, everyone, and yeah, that's it.
I have a question. So we isolated at least one potentially significant bacteria. So would you suggest spraying the dunes with one bacteria or a combination of multiple?
I would say for now to test it, just the one sample, so it can then aggregate into the entirety of the year and see how that works.